Now you get to practice showing outer shell electrons, dot and cross diagram, showing the formation of these particular one. You have to think about very carefully about stuff like sodium oxide. So there is a name. These are names of compounds. These are names of ionic compounds. So you need to slowly build your vocabulary. So we know sodium is 2H1 from group 1, period 3. When it likes to form ions, it likes to just lose the outermost shell electrons and you get 2H. And then of course oxygen, when you have oxygen atom is 2,6, so group 6, period 2. When it wants to gain 2 electrons, is the easiest for it. Gain 2 electron, therefore you will get O2 minus. You gain 2 electrons. Your atom has equal number of protons and electrons. When you gain 2 electron, you have 2 extra electron than your proton, and you have 2H electronic configuration, the same as neon, fully filled outer shell electrons. Okay. So now, if you just draw the dot and cross showing the outer shell electron, then I'll get, what will I get? Oops, no. All right. Okay, so dot cross, well, actually dot cross, I want to show 8 outer shell electrons. And I will show it as Na, and I'll show it as a plus there. Outer shell electrons, there are 8. I show the Na there as a symbol. And then I put a square bracket around it, and I put the charge very clearly is +1. That's why we don't put the 1 there. What about the oxygen? The oxygen will have 8 as well in the outer shell. So usually these days we draw in pairs because it's easy to count 2, 4, 6, 8. If you know the electrons are not just staying there, they're actually always moving, so they are not static. We are just drawing them in pairs because they are easy to count. 2, 4, 6, 8. If you're all over the place, it's very difficult for you to count to make sure that you got everything correct. It's also very difficult for the examiners to count as well. This is 2 minus based on the charge there. So group 6 atoms like to gain 2 electrons to get to fully filled outer shell. Now I have a +1, I have a 2 minus. +1 and 2 minus do not cancel each other out. When I form ionic compound between Na plus and O2 minus, I would have to balance the charge because compounds are uncharged. Be very careful. Compounds are uncharged, just like atoms. Uncharged overall. I'm not saying that it doesn't have charged species. Of course, ionic compound would have charged species called cation and anions. That's how you get ionic compounds. But overall, it must be uncharged. Whereas ions are charged. The individual species that make up the compound, ionic compounds, are charged. So how do we balance the charge +1 and -2? I cannot change this because the charge is determined by the electronic configuration that you want to achieve, the noble gas electronic configuration that you want to achieve. Therefore, you have to gain 2, you have to lose 1. So what do we do? How do you come to a common point? You do a lowest common multiple. I don't care about the plus and the minus at the moment. I need to balance 1 and also 2. This is called lowest common multiple. I did this when I was in primary school. So the LCM of 1, which is +1, and 2, which is 2 minus here, is equal to 2. This is already 2 minus. So how do I go to 2? Well, 2 minus to 2 is already just multiplied by 1. So I just need 1 unit of this. Just need 1 unit of this anion. But this is a +1. I need to get it up to 2. Okay, for the plus, I need it to be +2. For the minus, I need it to be -2. But this is already -2. That's why I just need 1 of it. This is a +1. I need it up to go to +2. Okay, so I need 2 units of this. So what am I saying? I'm saying that, to get the formula to be balanced, I actually need the ionic compound to be this, and I actually need it to be this, and I also needed 1 of these in order to balance the charge. Is that balanced now? I think that is just balanced. I probably need to move this around a little bit. And there you go. So what have we done here? This is showing 2 Na plus and 1 O2 minus. Plus 1 is plus 2, minus 2, the overall compound is uncharged. When you total up, how many sodium are there? There are 2 sodium and there's 1 oxygen. So the formula for sodium oxide is going to be Na2O. So that is how we get the formula representation from the ions itself. If I write it in another form, it's actually Na plus bracket 2 and then O2 minus bracket 1. 1 of these and 2 of these. How do I get that? I know how they get the ions, and I just think about lowest common multiple, cancelling out the charges, drawing all the full outer shell electrons. Full does not always mean 8. Be careful, because helium is second element in the periodic table. Helium is in the first shell. Maximum you can have for helium is 2 electrons in the first shell. So I've already done for sodium oxide. You can do for magnesium chloride, magnesium oxide, lithium chloride, and calcium fluoride. And I'll go through it in the next tutorial video. We'll also continue the properties of ionic compound. So thank you for watching, and I'll see you in the next video. Hello again everyone, welcome back to ptet.chemistry channel. So in this second part of lecture tutorials on chemical structure and bonding, I will specifically continue on ion and ionic bonding. In the last lecture tutorial video, I talked already very briefly on how we get the positive ions and how we get the negative ions, on top of what we already learned from the previous topic on atomic structure. We also learned that we need to identify giant ionic lattice structure is a regular arrangement of alternating positive and negative ions, such as this one here. So in reality, this is a giant ionic lattice structure, but in simple representation, we always represent them with this kind of dot and cross diagram, where we need to describe using the diagram the formation of the ion from the atom in terms of the electronic configuration, in terms of their position in the periodic table. The metals prefer to lose electrons in order to achieve a noble gas electronic configuration with the fully filled outer shell. The same thing with the chlorine, being a non-metals, prefer to gain electrons to achieve the fully filled outer shell or valence shell. And that was to get the cations and the anions, and as a result you get a strong electrostatic force of attraction between the oppositely charged ions that you get as a result of transferring electrons from one metal atom to the non-metal atom, and that is how you get the ionic bond being formed. The ionic bond is the bond, the giant ionic lattice structure is the structure. Okay, this is a simple representation. In reality, it's a giant lattice structure with alternating cations and anions, and they are repeated array, and these are all ions held in a fixed lattice, especially because you're in the solid state, and we'll talk more on properties in the later part of this particular lecture tutorial. I started with this one example in the last bit of the last lecture tutorials, where I show you how to get sodium oxide. We also talk about the charges on the sodium ion and the oxide ion do not balance out, unlike the Na plus and Cl minus, where the charge balance out, but Na plus and O2 minus, the charge don't balance out. So we did something called lowest common multiple. To balance out the charge, the lowest common multiple between plus 1 is just 1 and 2. Without caring about the charge, I just need a common factor for me to bring the charge to a common factor, such that I can cross out the charge, I can cancel out the charge. That means I must only have 1 unit of this, because the LCM is 2, this is already 2 minus, so I just need 1 unit of this. This is a plus 1, I need to get up to the LCM of 2, so I need 2 of the plus 1 in order to balance out 1 of the minus 2. Alright, so it's just like 2 times plus 1, and this is 1 times minus 2. 2 times plus 1 give you plus 2, and 1 times minus 2 give you minus 2, which, plus 2, which means overall you get 0. So ionic compounds overall are uncharged, although the ionic compounds contain charged ions. Be very careful there. Right, so you need 2 of the Na plus, and you need 1 of the O2 minus. The next examples include magnesium chloride, magnesium oxide. If we look at magnesium, so magnesium is in the period 3, group 2. So you have magnesium atom. You start off from the valence shell for the atom. So you will have, I know I made a mistake in the last video. I know why already, okay? I just remember. The electrons on the oxide, which has gained 2 extra electrons, come from the sodium, right? So I cannot just use cross on all of them. I should really use dot for the remaining 6, because the original electrons on the oxygen must be distinguished from the 2 extra electrons that it gained from the metal, okay? So when the metal loses the one outer shell electron from the third shell, your outermost shell become the second shell automatically. So I just show the second shell, which is fully filled, and I show 2 electrons coming from 2 of the Na plus, because I need 2 of the Na plus, which means that this is a mistake as well. I should really use a dot. So yep, there was a mistake on my part, so there was a dot like that, okay? So magnesium atom, so it's not like the metal has to be cross, okay? You can use dot as well if you want to. So for example, magnesium, the atom is just 2 electrons in the outermost shell, 2 at 2, right? So third period, group 2, 2 outermost shell electrons. Now when you form magnesium ions, the magnesium likes to lose 2 outer shell electrons, all right, in order to get the noble gas configuration. And now your outermost shell become the second shell, because you lose the outermost third shell, 2 electrons from there. Now you have 8 electrons in your outermost shell. This is just 2, 8. This is actually a cation already, because it's a 2 plus. Alright, so this is not a cation, this is an atom. This is a cation because it has lost 2 electrons. And now your outermost shell is now the second shell. And what was it just now? Chlorine atom. Chlorine atom will give you a chloride ion. So sooner or later you learn the name. The names are very particular. Chlorine is the atom, is the element, and chloride is the ion. So I'm going to draw chlorine atom using there you go, I make a mistake again. Just now I said I should use dot for magnesium. You can also use cross, however, but you need to be consistent. I just want to show you that it does not matter which one you use, which means I would have to use cross for chlorine. So I know chlorine is in group 7, so it's got 7 outer shell electrons, 2 at 7. We draw in pairs, not because the electrons like to stay to each other, simply because it's easier to count 2, 4, 6, 7, alright? And when you gain electrons, then you would form an ion. You will gain 1 electrons and you have -1, because you already have 7 outermost shell electrons, so it's just 2, 8, 8. So now you have 7 crosses, your original 7 outer shell electrons. You also gain 1 from the magnesium. But the magnesium is more than happy to lose the 2 outer shell electrons, but each chlorine only gains 1. And this is where the charges, you have to look at the charges again. 2 plus and a -1. The lowest common multiple between 2 and 1 is again 2. You don't need to do the LCM all the time. You should be able to see that you need 2 of the -1 to balance out 1 of the +2 in order to reach the LCM. So in reality, so your dot and cross would be 2 of these. Hang on, let me see. 1 of these, 2 of these, and then you have 1 of the magnesium 2 plus. And that should be nice and happy as an ionic compound. Nope, so that is nice and happy as an ionic compound, 1 Mg2 plus and 2 Cl minus. So therefore, the formula, just by looking at this, the formula will be 1 Mg2 plus and 2 of the Cl minus, and you will get MgCl2. The overall compound is uncharged, and you have Mg2 plus and Cl minus. Okay. The other one given in the asked in the question was magnesium oxide. So you have magnesium 2 plus and you have O2 minus. I don't want to draw Mg2 plus again, and O2 minus was actually previously drawn for for this one already, so you should know how the oxide ion was formed from the oxygen atom. So this is oxide ion, this is oxygen atom. So being quite straightforward, here you have a 2 plus and here you have a 2 minus. You can think about the LCM again, of course, but the LCM simply give you 2. That means 2 plus going to 2 is just 1 unit of this, or 2 minus going to 2 is just 1 unit of it. Therefore, you can just think about, if I have 1 unit of this and I have 1 unit of this, then the formula is going to be MgO. Overall compound is uncharged. Drawing the dot and cross, however, is something you need to practice with. When the magnesium loses the outer shell electrons, it will have 2,8 configuration. This will be magnesium 2 plus. It has already lost the 2 outermost shell electrons in the third shell. Now you have 8 electrons in your new valence shell. And O2 minus, so square bracket, O, and I have to show the oxide gain the 2 electrons from the metal atoms that loses the electrons, and the original dot here refers to the original 6 valence electron present in the oxygen atom. I have gained 2 extra electrons, then I'll have 2 minus charge. Alright, so this is also 2,8 configuration. This is the dot and cross representation, simple representation for the ionic compound, which is between oppositely charged ions. I have oppositely charged ions attracted to each other, and they are actually alternating positive and negatively charged ions in a giant ionic lattice, which you don't see by looking at this. You think it's simple, but it's not. Ionic compound exists as a giant ionic lattice structure. Alright, so I don't think I will go through the rest of the examples. You can do it on your own. Lithium is a tricky one, so remember that lithium is 2, 1. So when you form Li+, it's just 2 valence electrons remaining in the shell. Okay, a common mistake is students always draw 8 and they always think like 8, but they can't even count the most basic electronic configuration of what you started with. Chloride you already did before, so chlorine is 287, so chloride will be 288. So you have LiCl as the formula. And calcium fluoride is going to be CaF2. Fluorine being in group 7 as well, it's going to look a bit like chlorine. When you form chloride, you will gain 1 electrons. So F minus, Ca2 plus, you need 2 of the F minus. You should practice drawing them on your own and see that you can get all of them correct as well. I'll just very quickly now go through the last remaining bits on ionic compound, which is to do with properties. So properties are very important because it's to do with application, and the question will always start off nice and easy, asking on definition, counting the protons, electrons, that kind of thing, and then it will ask you on draw dot and cross, which you should be able to do now, and then they'll ask you properties, or they will give you a table and they will ask you to explain why this shows there is a ionic compound. That means you need to know properties, high melting and boiling point. Non-volatile is the same as not volatile. Volatile means boils easily. If someone is volatile, that means that person gets angry easily. Someone is volatile, that person gets angry easily. The person reaches the boiling point easily, essentially, like, literally becoming so angry. So not volatile means does not boil easily. Not volatile means does not boil easily. That is because, so stating is easy, explanation is always required. Okay, you need a large amount of energy. You have to specify a large amount of energy required to break. Overcome is the same as break. You can use either. Strong ionic bond, strong ionic bond, which is referring to the electrostatic force attraction. You have to specify this ionic bond, even though it's not stated there. Specify is the strong ionic bond between the oppositely charged ions in the solid as well as the molten liquid state. Right? Talking about the solid when you talk about melting point, you talk about the liquid when you talk about the boiling point. All right. The next bit is to do with conductivity. Conductivity of electricity when molten. So there's a difference, as I mentioned earlier. A solid ionic compound is a pure substance. The ions are fixed. Fixed meaning fixed position. Fixed position. Why are the ions in fixed position? You just look at solid. Think of your stats of matter. The ions are arranged in a regular arrangement, and they only vibrate about fixed positions. They are not mobile at all. They are not freely moving. Okay, so not mobile. To get conduction of electricity, you need the ions to be free, or you need the ions to be mobile, means can move around, and that is only true when they become molten. Molten means you melt it. Okay, so from solid to liquid, you have to undergo melting, and that is at the melting point. When you become liquid, then you can conduct electricity because you have mobile or free ions. How about aqueous? Aqueous is not solid, it's not liquid, it's a mixture. Because it's a mixture means it's in water. Aqueous means in water. So you have a mixture, you have Na and Cl in water. So what you have then is you have Na plus, Cl minus, and you have H2 or molecule. You have ions, you have molecule. They are together as a mixture, and the ions are free to move around in the presence of water. Alright, that's why salt can dissolve in water, because you don't see the salt anymore. Alright, and that is because the ions dissolve in it to give you aqueous solution, and the ions are free to move around. And when you have the ions free to move around, unlike in the solid state, then they can conduct electricity. Two major differences: melting versus dissolving. This is a pure substance. Pure substance melt at a fixed melting point. Pure substance also boil at a fixed boiling point. States of matter, heating curve, horizontal line, fixed boiling and melting point. This is dissolving. Pure substance plus water, pure substance, mixture. This is dissolving. Alright? We don't really do much on hard and brittleness in ionic compounds, so you can forget about this, but this is just here for you to read on your own. They will make much more sense when we come to properties of metals. For metals, you have to know the properties in terms of brittleness, as well as some other properties of metals. But for ionic compound, as stated in the syllabus, melting and boiling points are high, good conductor of electricity when molten or aqueous. When molten or aqueous. You see, when molten or aqueous. Maybe I just highlight that. When molten or aqueous, but does not conduct when solid. Alright, so very important, does not conduct when solid, because no free ions. The ions are in fixed position. Think on your states of matter topic. That's it for this short lecture tutorial, part 2 of ionic compounds, and I'll see you in the next video. So hopefully that was useful, and in the next video we'll continue on covalent bonding.